Good morning. I hope that you're doing well. Today we're going to continue talking about segments. Before we do that, though, let me remind you, in case you haven't been looking at RenWeb or at Google Classroom, about what's coming up. Tomorrow you will have a quiz on section 1.1 in your book. That will be the two homework assignments that were due last week, the worksheet and that first assignment out of the book, which was on page 9. Those are the things that are going to be on the quiz. So I would suggest that you spend some of your time um, between now and tomorrow uh, reviewing that material, making sure that you understand it. So today we're going to start off with something called the segment addition postulate. Before we dive into that, we're going to talk about, well, what is a postulate? So a postulate is a statement that we accept as being true without ever having proved that it's true. Usually in geometry, these are things that people look at it and they go, well, of course that's true. And they provide the underlying basic ideas for all of geometry. Um, it turns out that when you have other kinds of geometry, like spherical geometry, there are a different set of postulates, a different set of basic assumptions, and because of that, you get completely different ending points for the geometry. The kinds of things you do, you know, in spherical geometry, you can have a triangle that has more than one right angle. In the geometry that we do, you cannot. So let's jump in with the segment addition postulate. It says that if B is between A and C, by the way, it doesn't have to be those letters, it's not really important, then we know that the length of AB plus the length of BC is equal to the length of AC. And you can think about this as if you were traveling along a straight road. If you were going from A to C, if you were to measure how far it was from A to B, and then measure how far it was from B to C, all you would have to do is add those two lengths together to get the length of your whole trip from A to C. So let's do some example problems. On all of these, we're going to make a diagram real quickly. It doesn't have to be a work of art, but a diagram is, making a diagram is one of those things that frequently is really helpful in problem solving. This is one of the things that I think geometry kind of pounds into your brain after a while, that if you can't immediately kind of picture it in your head, then you probably need to make a diagram. So here, it says that R is between S and T. In order to be between, they all have to be on the same line. So those points have to be collinear points. So R is somewhere between S and T. Now, one of the things to note here is it doesn't say where between. So I'm not going to put it exactly halfway between. I'm just going to put it somewhere in between. And I'll label these. R is the point that is between S and T. And I'm going to stop there. Before I do anything else, we can look at that and go, okay, I know that the length of these two shorter pieces, SR and RT added together, are going to be equal to the length of the whole thing. I may or may not use that on this problem. I don't know yet until I know the other things, but that's something to be thinking about as soon as you see this. So the length of SR is 17, so I'm going to put that right here. And the length of TR is 8. And you may go, your diagram's not very good, Mr. Davis. Well, it's not to scale by any stretch of the imagination. But I didn't look at which one was longer to start with, and it has nothing to do with the problem. And we're looking for the length of ST. That's this whole segment from here to here. And that's the way I'll typically draw that. So I'm going to start with, what does the segment addition postulate tell me? It tells me the length of these two short pieces added together, or the length of the whole piece. And I would strongly recommend that you start by writing the general formula. That is, this piece, the length of SR, plus this piece, the length of RT is equal to the whole thing, which is the length of segment ST. Remember, the way we say the length of a segment is not to put a segment bar above it. It's kind of a weird symbol. I'm not a big fan of it, but this is the way geometry has been done for thousands of years. So I'm going to now substitute in what I know. The length of SR is 17, so I'm going to replace SR with 17, plus the length of RT, or TR. RT and TR, those two lengths are the same, so that's 8 is equal to the length of ST. And then you have 25 as the length of ST. Again, I strongly recommend that you do it this way. However, at the very minimum, I expect to see this part. You have to show me how is it that you're finding ST. If you're just writing down ST is 25, you'll get a point or so for finding the right answer, but you need to have work to go with that. On homework, I'm going to be real insistent. You got to show me where that's coming from. How did you get 25? Okay, you're adding those two together. It doesn't take but a second to write it down. I don't think that that's too much of a hardship for you. So I require this. I suggest that you write the original equation. Get in that habit. I think it's real good for you. All right, let's do another one that is a little bit different than that one. So again, it says that K is between J and R. That means I have a set of collinear points. So I'll need at least a piece of a line to put them on. It says K is between, and again, I always make sure not to put it exactly halfway in the middle, between J and R. And if you wanted to put J over here and R over here, that's fine, doesn't matter. The length of JR is 38. Oh, this time it gave us the length of the whole thing. And the length of KJ, which is the same as the length of JK, is 22. And we're looking for the length of KR. So again, I'll start with the very basic. The segment addition postulate tells me that the length of these two shorter pieces is equal to the length of the whole segment. So the length of JK plus the length of KR is equal to the length of JR. Remember, no segment bars above it when we're talking about the lengths. So now I'm going to substitute in what I know. I know the length of JK is 22 plus the length of KR, that's what I'm looking for, is equal to the length of JR, which is 38. So to solve that, we'll simply subtract 22 from both sides. So the length of KR is 16. Again, this is not an absolute requirement that you write this one. I think it's a good idea. You're more likely to get partial credit if you write that. At the very least, you have to show me that you're subtracting 38 minus 22 to get that KR is 16. All right, let's go on. Are all the problems just with numbers? No. Sometimes there are going to be algebra problems with these. For example, if S, I don't know what happened here, is between R and T, and the length of RS is equal to 4x plus 1. Oh, now we have a variable involved. The length of RT is 6x, and the length of ST is 29. Find the length of RS. All right, so that's sufficiently complicated to where I think you really, really need a diagram and an equation to start this one. Anytime we have an algebra problem, you must show your equation on your piece of paper, not on some mythical piece of paper that you left at home. So S is between R and T. So S is the one in between. points R and T. The length of RS is 4x plus 1. I'm going to have to write a little bit small, but it's fine. If you write large, you may want to make your diagram pretty big. The length of RT is 6. It should be 6x. So that's this whole thing. And the length of ST is 29. So we want to be able to write an equation for that. So again, I'll start with the general equation. The length of these two smaller pieces added together, that is the length of RS plus the length of ST, gives me the length of the whole segment, which is RT. So the length of RS plus the length of ST is equal to the length of RT. Start with the basics. That's the segment addition postulate. The length of the two short pieces added together gives you the length of the whole segment. Then I'll replace each of those with what I know. I know the length of RS is 4x plus 1. The length of ST is 29. And the length of RT is 6x. And at this point, it just becomes an algebra problem. And this is why it's required that you have passed algebra before you can take geometry. So here I would combine the like terms and make that 4x plus 30 is equal to 6x. Subtract 4x from both sides. And we end up with 30 is equal to 2x. Divide both sides by 2. Then to find out just what 1x would be, we get x is 15. Be really careful. In algebra, you are frequently just solving for x. In geometry, a lot of times you won't just be solving for the variable, you'll be going on to find some length. Here specifically they say, find the length of RS. Oh, and by the way, occasionally I'll have someone say, well, the length of RS is 4x plus 1. Well, yes, I've already told you that. That's not the answer to the problem. I want a numeric answer for the length of RS. So the length of RS is going to be 4x plus 1, but the x has a value of 15. So that's 4 times 15 plus 1. Let's see, 4 times 10 is 40. 4 times 5 is 20. So add those together, that's 60 plus 1. So I get my final answer. The length of RS is 61. And I'll circle that so that it's easy to find on a piece of paper. Let's do one more like that. This one doesn't have any segment that just has a length. They're all in terms of x. They're all in terms of an algebraic expression. So let's do that. So it says B is between A and C. All right. So that means I need a segment. So B is somewhere between A and C. And someone once remarked, why do you always put B closer to the left? I don't know. I just do. It doesn't matter. I just don't want it exactly halfway in the middle. And then it says the length of AC, that's the whole thing, is 8x minus 3. So from all the way from this end to this end. Then the length of BC is 2x plus 5. And the length of AB is 4x plus 10. Now we can use the segment addition postulate to write the general equation for this. The length of the two short pieces added together gives me the length of the whole segment. So the two short pieces, the length of AB plus the length of BC is equal to the length of AC. That's the segment addition postulate. Remember, no segment bars above these when we're talking about the lengths. Anytime we have an equation, there will not be any segment bars on those. So the length of AB, I know that that's 4x plus 10. The length of BC is 2x plus 5. and the length of AC is 8x minus 3. Joining the like terms here, that's going to be 6x plus 15 is equal to 8x minus 3. I almost always move the x's first when I'm solving equations. I always subtract the smaller one from the larger one. So that's going to be 15 is equal to 2x minus 3. Add 3 to both sides. I get 18 is equal to 2x. I don't know about you, but I'm out of room at that point. So now I'll divide both sides by 2. And I get the value of x is 9. I check back to see what it is that I'm asked to find. It says find the length of BC. In terms of x, it's 2x plus 5, but I want a numeric answer for that. So BC is 2 times the value of x is 9 plus 5. That's 18 plus 5. So the length of BC is 23. Okay, so now we're going to do some problems involving midpoints. It's kind of similar, but not quite the same. So let's take a look at some midpoint problems. Here it says that if T is the midpoint of segment JD, and let's stop right there for just a second and remind ourselves, what is a midpoint? The midpoint of a segment is the point that divides that segment into two congruent segments. Remember, congruent segments are segments that have the same length. So we actually need to know two definitions to help us with this. The definition of midpoint, which says that that's a point that divides one segment into two congruent segments. And then it's like, well, what's congruent mean? Congruent segments are segments that have the same length. So I'm going to draw a picture of this. It says T is the midpoint of JD. This time I'm going to put T right in the middle because it says that it is the midpoint. Well, it's pretty close to right in the middle. But remember, I can mark that with a little slash across these to let me know those two lengths are the same. Then it tells me that the length of DT is 14, and that's all it tells me. And then it asks for the length of JD. This is what we're looking for. So the question becomes, well, what the heck am I supposed to do? I could try the segment addition postulate. JT plus TD is equal to the length of JD, but there are two things that I don't know. That's not going to work out very well. But here's the key. Since these two segments are congruent, they have the same length. So if the length of DT is 14, the length of JT is also 14. Now I can use the segment addition postulate. The length of JT plus the length of TD is equal to the length of JD. The length of JT is 14. The length of TD is also 14. And that's going to give me the length of JD, when I add those together, is 28. Not all midpoint problems give you 1/2. Sometimes they give you something else. Let's take a look. For this problem, it says N is the midpoint of, I don't know where my segment bar went on that. That's my fault. Sorry about that. That should have a segment bar above it. When we're talking about a physical object, we're going to have the segment bar. When we're talking about a length, like here, we're finding the length of Pn, that will not. So, quick diagram. N is the midpoint of segment PQ. I'll try to get it exactly in the middle this time. And it's still a little further to the left than it should be, but we'll live. It's the midpoint. The midpoint divides that segment into two congruent segments. So I know the length of PN and the length of NQ are the same. Then it tells me the length of PQ is 17. Oh, that's plot twist. This time they gave me the whole length. And we're looking for the length of PN. And you may think, well, the segment addition postulate isn't going to help because I don't know PN and I don't know NQ. However, I know the length of PN and the length of NQ are the same. So if I started with the segment addition postulate, PN plus the length of NQ is equal to the length of PQ, I can do something clever. I want to know PN, and the length of NQ is the same length as PN, so I'm going to say that's the same length as PN, so I'm going to call it the length of PN this time, because those two lengths are the same. And the length of PQ is 17. PN plus PN, well, that's 2 PNs. And now we can divide both sides by 2 to solve this. The length of PN, 17 divided by 2, is 8.5 or 8.5, and I don't care which way you write it, either is just fine. So with the midpoint problem, sometimes they'll give you the length of half of it, sometimes they'll give you the length of the whole thing. Again, on these problems, if you don't want to go through the segment addition postulate part, you don't absolutely have to. However, you must show me how you're getting your answer. So like on this one, you would have to show me that you were adding 14 to 14 or multiplying 14 by 2. On this one, you would have to show me that the way you're doing this is dividing 17 by 2. You have to show where your answers come from. You can't just say, well, I did this, on another piece of paper or on a calculator, which you're not supposed to be using. So show me how you got your answer. Sometimes the midpoint problems will be an algebra problem. And again, if it's an algebra problem, if you don't have an equation in all your work, you get 0 credit even if you have the right answer. So let's read this. If B is the midpoint of segment AC, the length of BC is 3x minus 7, and the length of BA is 5x minus 23. Find the length of AC. There is a lot going on in this problem. Let's take a look. So it says B is the midpoint of segment AC. Yeah, it's closer to the middle than either of my other ones have been. And I'm going to mark that those are congruent so that I don't forget it. Then it tells me that the length of BC is 3x minus 7. And the length of BA is 5x minus 23. And notice they didn't tell me anything about the length of AC. That's a pretty good indicator that to solve this, I'm not going to be using segment addition postulate at all. Because I know nothing about the length of AC at this point. However, I do know that these two are supposed to have the same length. And you're like, well, one of them is 5x minus 23 and the other one is 3x minus 7. That doesn't look the same. Well, what our job to do is to find a value of x that will make these the same length. So we want the 5x minus 23 to be equal to the 3x minus 7. These two segments are congruent. Congruent segments have equal lengths. So again, I always move the x's around first when I'm solving a linear equation. So that's 2x minus 23 is equal to negative 7. I'll add 23 to both sides. Oh, look, we're adding a positive number and a negative number. We get to practice that some more. So when I do that, I'm going to subtract and take the sign of the larger number. Let's see, that's 6, this is 16. Divide by 2, and I get that the length of x, or the value for x is 8. But they asked for AC. Well, that's not particularly helpful. I don't have anything about AC. Well, when that happens, we find whatever we can find. We can find the length of AB. The length of AB is going to be 5 times x, which has a value of 8, minus 23. That's 40 minus 23. The length of AB is 17. Well, I know that the length of both of these are the same because they're congruent. You can substitute the 8 in for the x here and find it, or you can just say, well, that's got to be 17 also then. And now I can use the segment addition postulate to figure out the length of AC because I have the lengths of the two pieces. So I know that the length of AB plus the length of BC gives me the length of AC. The length of AB is 17, plus the length of BC also 17. So that's 34 for the length of AC. That's a pretty involved problem. Let's do one more. This one is also pretty involved. Let's see, R is the midpoint of segment of QS, and then it gives me the length of QR is 4x plus 12, and the length of QS is 10x minus 18. So let's see what's going on here. I need my segment. I want R to be the midpoint, so I want it to be exactly halfway in the middle. Again, mine's too far left. It's sort of a perpetual problem for me, but I'm going to mark these two as congruent. So even though they don't look perfectly the same, it's pretty close. And the marking tells me to ignore the fact that this isn't perfectly in the middle, but to rely on the fact that I've marked that these two are the same length. So the length of QR is 4x plus 12. And the length of QS is 10x minus 18. And now I'm supposed to find the length of RS. Now on the previous one, I knew the length of the two smaller pieces, at least in terms of x. Here I don't. And I can't call this x just because I don't know it. So I can't do that. For this, we're going to have to be clever. We know that these two are the same length. So if the length of QR is 4x plus 12, then I know the length of RS is also 4x plus 12. Well, I want a numeric answer for it, so I need to be able to write an equation and solve for x. How can I do that? Well, notice I've got this part, and this whole segment all in terms of x. I can use the segment addition postulate. The length of QR plus the length of RS gives me the length of QS. The length of QR is 4x plus 12. The length of RS is also 4x plus 12. And the length of QS is 10x minus 18. This is the minimum starting place. I would start back here, but you have to show me this equation. Now I'll group the like terms, and I have 8x plus 24 is equal to 10x minus 18. Again, I always move the x's first. I always subtract the smaller one first. That's going to be 24 is equal to 2x minus 18. Add the 18 to both sides. That gives me 42 is equal to 2x. Divide by 2. I have x is 21. Again, on this one, they didn't ask us just to find x. They want you to find the length of RS. So the length of RS is 4x plus 12, so that's 4 times 21 plus 12. 4 times 21 is 84 plus 12 gives me that the length of RS is 96. All right, your assignment today is going to be a worksheet that your substitute will give to you. That's your homework for tonight. In addition, don't forget to study for your quiz tomorrow. Hope you have a great day. I miss seeing you guys, and I'll look forward to seeing you hopefully later this week.